Hello everyone and welcome to my channel, and my name is Victor Iberi, and in this video I will be talking about correlation and regression. So what is correlation? So correlation it checks if there is a connection or relationship between two or more things. So I always use this example. If, let's say, heavy rain falls on a Sunday morning, let's say from 5 a.m., rain starts to fall, can it affect some persons from going to church? Yeah, I think it can. Some persons might not go to church. Some persons might not actually want to go out in the rain. Some who don't have cars might not want to go out, and it might affect some persons from going to church. So there is a positive correlation between rain falling and people going to church on a Sunday morning. But if sun shines on a Sunday morning, let's say from 5 a.m., sun shines throughout the day, I don't think it doesn't have any correlation. It doesn't affect people from going to church or not. So you can see that there is no relationship between sun shining and people going to church on a Sunday morning. But there is when rain falls. So that's an example of correlation. It checks relationship between two or more variables. Now, there's what we call the independent variable and what we call the dependent variable. So I choose to see the independent variable as the cause and the dependent as the effect. So if rain falls, it might affect some persons from going to church. So rain falling is the cause. You can call it the independent variable. Now the effect is whether some persons will go to church or not. So you can see that rain falling is the effect, or the independent variable, and then the result, the effect, is whether some persons go to church or not. So now I have a small data here, so you can see I have on my column B I have hours studied, and then on my column C I have exam grade. Now this is a very small data. This is not the most ideal data to work on correlation and regression, but I'm using this. The same way you use this is how you also did for a big data. So I have hours studied. I want to check if number of hours studied can affect exam grade. So let's assume these are my two columns. They're just 13 in number. So this guy studied for 8 hours, 11 hours, 3 hours, 6 hours. Now let's compare their exam grade and see if there is any relationship between hours studied and exam grade. If hours studied affects exam grade. So if there is a correlation between hours studied and exam grade. Okay, so the very first thing I'll do is I'll go to the data pane. I'll go to the data pane, and then if I go to the right hand side, I can see there's what I'm meant to see here. I'm meant to see data analysis, but it's not here. But that's no problem. Here is this. Okay. I'm meant to see data analysis. So if you already have data analysis, you don't have to do what I'm about to do now. So I want to bring out the data analysis ribbon to be here. So all you have to do, you can see I'm hovering around this empty space here. I'm just hovering around it. Now right click on it, then you will see customize the ribbon. So click on customize the ribbon, then okay, now you have this. Now click on add-ins. So click on it. So after you've clicked on it, on add-ins, give it time. Okay, so after you click on add-ins, you see this next screen here. Click on go, that is here. So click on go, and then you have this this dialog box comes up. So you can check the first two, the 2-pack and the 2-pack VBA. Then click on OK, and that's just it. And that's it. So if you go back and click on the data ribbon, so you can see we have what? Data analysis here. Okay, that's good. So all I have to do now is I have to click on what? Data analysis. I have to click on it, click on the ribbon there, and then I have a whole lot of options here. Now I want to do correlation, but then I'll go down and choose what? Regression. So I'll choose regression. And if I click on regression, I'll click on what? Okay. Okay. Now the X range is the independent variable, which is what? The cost. And in this case is the what? Hours studied. That is what will affect if you might have a high exam grade or not. And then the Y range is the what? The effect, which is the what? Independent variable. In this case, it's our what? Exam grade. Okay, so all I have to do is I'll click on this box here, this little arrow for the X range. I'll click on it. Then take note. I'll begin from B1. Now I'll press Ctrl Shift down. I'll select what? My entire B cell from B1 to B14. Then after that, I'll go and click on this small arrow here to take me back to this box. Then for the Y range, I'll click on this Y range. Then I'll select what? From C1 to C14, which is my exam grade. Then I'll go and click on this arrow. It takes me back to my dialog box. Now, because I could see C1 is from the what? Exam grade and the hour studied, I added the labels. So I'm going to click on what? Labels. And that's all. And I'll click on OK. And then this is it. I now have what? The output. Now, let me expand this. So this is our result. And then of all this, what is important the most is, let me call out, is this one called the multiple R. I'm going to highlight it. This other one here, I'll also highlight it, and this one here. Okay, I can expand this. Okay. Now the multiple R is the value of our what? Correlation, and it is expressed as a percentage. So this is 0.86. So this means 0.86 times 100. This shows that what is what? 86%. Now correlation value is from 0 to 1. So if it's 0, that means there is no what? Correlation. If it's 0.5, that means there is an average what? Correlation. If it's 1, then there is a perfect what? Correlation. Now 0.8 is a little bit high. It's a high what? Correlation. So this is 0.8, 86%. So what this means is that those who study for longer hours have an 86% chance of getting a higher exam grade. Now, but in statistics, we don't just do this and write the result. There's what we call p-value. So if you look here, I colored this guy here. You can see 0.000160053, and then this other one here. Now you can see that this value here and this value here, that they are the same. I colored them. They are the same. This is the p-value. Now what is p-value? P-value is what helps us to check if we are correct in our what analysis. It shows to what extent is our what analysis correct. Now there is this normal thing we do in statistics. that if the p-value is less than 0.05, we accept the alternate hypothesis. Okay, now I know that most of you may not understand this, so I'm going to create a demo. I'm going to create something that I will explain this in details. Okay, let me get to my notes. Let me open my notepad. This shouldn't take time. Okay, so what I'm going to do here in the notepad, I'm going to give an example here. This is okay. Let's create a new one and then maximize this. Okay, so now I'm going to conduct a small experiment here. Now I can ask a question: does eating, I have to make this capital letters. Does eating after 8 p.m. lead to obesity? Okay. Now, what I will do here now, let's assume I want to conduct this experiment to check if eating after 8 p.m. can lead to what? Obesity. Now, I can conduct several tests, and then this set of people will be eating after 8 p.m. The rest will not. Then we'll check over time. I don't know how long it can take, and then we'll now observe if they are obese or not. Now, after that, we can now check if eating after 8 p.m. can lead to obesity or not. Now, this is just like a rough example. Now, there's what we call, the main thing I want to explain to you guys is what we call the null and the alternate hypothesis. Now, the null hypothesis, which is called the H naught, if I'm not mistaken. Now, it always negates the assumption. Now, it says no, eating after 8 p.m. does not lead to obesity. Now, we have what we call the alternate hypothesis. Now, it is always in agreement with what our theory or what we want to check. Here it is, what does eating after 8 p.m. lead to obesity? Now, the alternate is always in agreement. It says yes, eating after 8 p.m. can lead to obesity. Now, the very first thing we do is to get our data, carry out experiment, and then check if there is a correlation between eating after 8 p.m. and having what? Obesity. Now, we can involve other things into it, maybe genetics, if it's in their lineage or all that. But then let's say we have our data where we have found that our value of correlation. Now, let's say, for example, that our value of correlation is, let's say, 0.79. Now, this means what? 79%. So this means that 79% 79 out of 100 times that people who eat after 8 p.m. are likely to what? Get what? Obesity. Now, but we don't just assume that because we have a value of correlation that is 0.79, that will now say, wow, that this is almost 80%, that almost 80% of the time that if you eat after 8 p.m. it can lead to what? Obesity. We don't just accept this. We check if this is just, if it happens by chance, or if it is significant. We want to check if this value that we got here, if it's actually true, or if it's just happening by chance. Now we use what we call what? The p-value. The p-value double checks this. Now we said that if the p-value, if it's less than, if our p-value is less than 0.05, if it's less than 0.05, what do? We reject what? The null hypothesis. Now if we reject this, that means that we accept what? The alternate. That means we accept the alternate what? Hypothesis. But then if the p-value is more than 0.05, then what do? We accept what? The null hypothesis. We accept the null hypothesis. Then that means what? We're going to what? Reject the alternate hypothesis. Now I hope this is clear enough, right? Now we have our p-value. Let's assume that in this does eating after 8 p.m. does it lead to obesity? Now let's say we have our p-value of 0.79. This is almost 80%, which is quite a high correlation. Now, and our p-value, let's say our p-value here is 0.06, or let's say 0.21. Now 0.21 is more than 0.05, as you can see. So if our p-value here, let's assume that our p-value is 0.21, you can see it's more than what? 0.05. That means we are going to what? Accept the null hypothesis. Now, which says that no, eating after 8 p.m. does not lead to obesity, even though we found a high value of correlation at 0.79. It just happens by chance. This is not what? Significant. Now, but if the p-value was, let's say, 0.0005, now you can see that this 0.0005, you can see there are 3 zeros here, is less than 0.05. Then we're going to what? Reject this null. We're going to reject the null hypothesis, and then we're going to reject the null hypothesis, and then we what? Accept the alternate hypothesis. So we're going to reject this null hypothesis, which says that we're going to reject this one, and then we're going to what? Accept the what? The alternate, which says that yes, eating after 8 p.m. can lead to obesity. So the p-value acts as a check to know if our value is actually what? Significant. So if our p-value is this later one, 0.0005, then we can say that this is almost 80%, that 80 out of 100 persons that eat after 8 p.m. are likely to have what? Obesity. Or 80% of persons who eat after 8 p.m. are likely to have what? Obesity. Now let's take it back to this our data where we have what? Exam grade and hours studied and exam grade. Now what will the null hypothesis say? The null will say that no. Now first, what will be our assumption? Right, it will be, does reading for longer hours does reading for longer hours resonate in getting a higher exam grade? Now what will the null hypothesis say? The null will always what? Negate it. To say no, reading for longer hours does not lead to getting a higher exam grade. Why the alternate always agrees with our assumption? It says yes, reading for longer hours can lead to getting a higher exam grade. Okay, that's it. So now, what was our value of our correlation? So our correlation value, I think it was 0.86. 0.86. Let me go back to Excel. Where do I have this? So 0.86, good. Then our p-value was 0.00016. Then our p-value was 0.00016. Good. Now you can see that our p-value is less than our p-value is less than 0.05. Our p-value here is what? 0.00016. So our p-value is what? Less than 0.05. So we're going to what? So we're going to reject null hypothesis and accept what? The alternate. Now we're going to reject this null that says no, reading for longer hours does not lead to what? Getting a higher exam grade. And then we accept the alternate that says yes, reading for longer hours can lead to getting a higher what? Exam grade. Now this is how we now summarize our finding. You can say that students, you can say that it is 86 out of 100 students who read for longer hours are likely to have a higher exam grade. Or you can say 86% of students who study for longer hours are, you can see, very likely or likely to get a higher exam grade. This statistics is what? Significant, because our p-value is less than 0.05, and that's just it. So that's it about what? Regression. This is how you carry what? Regression what? Analysis, and then you find the correlation between two or more columns. Okay, you can see this is quite easy, simple, and short. So in my next video, I'll talk about how to build dashboards. You don't want to miss it. So all you have to do is what? Like this video, share, subscribe, and don't forget to turn on the bell notifications. So see you in my next video. Thank you so much, guys.